Hello, namaste. My name is Ram Bisra. This is my course, Big Data Analytics and Visualization. My instructor is Professor Rajan Nepal. Here in these presentations, I'm mainly going to focus into the topics Apache Storm and Apache Kafka among many modern big data analytical tools. First of all, let's introduce what big data analytics tool is. Big analytics tools is the software or engine that collect, process, and analyze enormous data sets to support outstandingly for better decision making. It has a capability of data storage, processing, integrations, visualizations, and real-time analysis. It is it lays out scalability, fast speed, cost effectiveness, and it supports diverse data types. It can be used in diverse fields like business intelligence, IoT, healthcare, finance, and e-commerce. Here is the technical overview of Apache Storm and Apache Kafka in a diagrammatic way. I will explain them into next slides one by one. Apache, here is technical overview of Apache Storm. The architectural components of Apache Storm is given by spouts, bowls, and topology. Spouts are data sources that emit streams. Bowls is responsible for processing, filter, and aggregate data. Topology. Spouts and bolts combinedly form of network and they define data flow. Uh, its model is working in a real time by distributions under parallel computations. The system is built by programming language such as Java, Python, Ruby, and there are other kind of programming language that can be applied to build up this system. Uh, Nimbus and supervisor combinedly make a cluster for data management. It uses zero MQ or native for fast message passing. Once the message is sent, then it is guaranteed for processing. The scalability is given by adding worker nodes. It works with Kafka, Hadoop, and Spark for complete big data pipelines. That is integrations method. So the next slide, the key features and functions of Apache Storm because of handling. Because of handling continuous streams of data instantly, it remains as a real-time processing. It distributes data across multiple nodes for high performance. The scalability is given by volumes of large data in a horizontal way. It detects a failure automatically and then it is recovered. Uh, it works in a real-time computations, uh, taking just a minimal delay. It means that it has a low latency because of consumption of less time for transmission. Works well with tools like Kafka, Hadoop, and Spark for complete big data pipeline, which is its integration point. It supports multiple programming languages such as Java, Python, which I have already mentioned before. Also, it can be used effectively and efficiently for real-time analytics for detection, log processing, and IoT data streaming. Here in this slide, uh, we will talk about the technical overview of Apache Kafka. The architectural component of Apache Kafka is given by producers, brokers, topics, and partitions, consumers, and keepers. Producers publish messages to Kafka topics, brokers serves, brokers stores and manage data streams. Topics and partitions organize and divide data for scalability. Consumers read data from topics and subscribe also. Zookeeper manages cluster coordinations and metadata. About processing a model, it distributes and publish a subscribe messaging system. Uh, the storage is log based, which is persistence for durability. The scalability is given by adding brokers and partitions in a horizontal way. It replicates data across multiple brokers for reliability, which is its point of fault tolerance. It has low latency for real-time streaming, and it has high throughput. Next slide. In this slide, we will talk about key features and functions of Apache Kafka. Uh, because of handling real-time data feeds efficiently, it remains as distributed streaming platform, same like Apache Storm. Uh, it processes millions of messages per second. It is a superhighway in a lightning speed. It transmits data, uh, realizing no traffic jam, especially the especially for Netflix and Uber. Uh, the scalability is given by adding more brokers in a horizontal way that have already been mentioned in previous slide also. It replicates data across server for reliability. It stores messages on back of disk to prevent data loss. It supports streaming analytics and event-driven systems. It works with tools like Spark, Flink, and Storm. It works in a real time, so it is responsible. It handles. It works for monitoring, messaging, and IT data pipelines. Here in this slide, here is about the comparison of Apache Storm and Apache Kafka. We can compare Apache Storm and Apache Kafka in features like primary functions, data processing, latency, data storage, scalability, use cases. The latency of Apache Storm is very low, is lower than the Apache Kafka, and the scalability of Apache Storm is based on the computations, but the scalability of Apache Kafka is based into the data throughput. The use case of Apache is remain into IoT monitoring and real-time analysis, whereas Apache Kafka we use it in a data it as a part of pipelines, log aggregation, streaming integrations. In this slide, here is about the business applications of both data tools. We have the category like real-time analytics, IoT, and sensor data monitoring system, e-commerce, finance and banking, telecommunication. So in this category, we can use Apache Storms and Apache Kafka. Uh, so when we use Apache Storm in a IoT field, then uh, it transmits the data from sensor, and then it instantly lead to the monitoring, which is a real time process. In the case of Apache system, the transmissions data from IoT, it undergoes to analytical systems. There are some challenges and weakness in the big uh, data analytical tools of like Apache Kafka and Apache Storms. The For both Apache Kafka and Apache Storm, there is a complex to set up. Um, the latency of Apache Storm is very low in the compare of Apache Kafka. Um, and Talking about fault recovery, the Apache Storms it has a weakness for error handling and debugging, and in the similar way, Apache Kafka has a weakness to replicate. Uh, if the replicate process is not proper, then data might be lost. Uh, the Apache Kafka needs high memory and it uses large data. In the case of Apache Storm, it needs high CPU for continuous streaming. Mitigation strategies of Apache Kafka and Apache Storms. In the case of Apache Kafka, mm, they have multiple replicas to prevent data loss. They have a proper design partitions for load balancing and scalability. It uses tools like Kafka Manager or Confluent Control Center to track performance. It implements periodic snapshots and disaster recovery plans for backup and recovery. It optimizes broker, produce, and consumer settings for throughput and latency. When you talk about the configurations tuning, another points related with Apache systems are as follows: reliable topologies, load balancing, fault handling, resource management, integrations with Kafka and Hadoop. Um, uh, in the case of reliable topologies, it could be better if it use acknowledgement mechanisms to ensure message processing. It could be better if Apache Storm distributes its pods and polls efficiently across worker nodes. Um, it could be appreciable if Apache Storm implements retry mechanisms and failure detections. Um it could exhibit remarkably if it monitors CPU, memory, and network usage to prevent overload. Similarly, it could be better if it combines with other tools for persistence and fault tolerance. This is the last slide, recommendations and conclusions. In this slide, we can conclude which want to recommend either Apache Storm or Apache, but both has their own importance. Um Apache Storm is uh, is better for IoT monitoring, fraud detections, and live analytics dashboards because it works in a real-time basis, and it has those kind of the level of the computations, and it analyzes the data instantly. Um, Apache Kafka is outstanding for message brokering and data pipelines management across systems. So when we combine both Apache systems and Apache Kafka, then many organizations has a benefits because Kafka for data ingestions and system for real-time processing. So in a union, they create an efficient end-to-end streaming solution. Thank you so much. I uh, complete out my uh, presentations here. If there is a question, please leave me in the comment. Thank you so much. Namaste.